Hello, this is Nadin and I'm here to guide you solve 4 diverse vector problems. So get your pencils and papers ready and let us begin. Initially, we are going to commence to solve a vector movement and position vectors question. The question states, here is a cuboid. The coordinates of some of the corners could be seen as per the following, which associates with the corners D, F, and G. These column vectors could be seen as x, y, and z. They could be graphically represented as 3 axes. This could indicate how the x term is equal to the horizontal distance of the point from an origin, whereas the y term is equal to its depth upon the surface, and the z term is equal to its vertical distance from the origin. With the initial question requiring us to identify coordinate b, we are required to identify the similarities between the provided values with the position of the coordinate b in terms of horizontal distance, depth, and vertical distance. Thus, we could identify a similarity in horizontal distance with known coordinate g to obtain a horizontal distance of 4 units from the origin, while in regards to its y term, to be known as its depth onto the shape, it obtains a similarity with point G, to be positioned at an equivalent edge of the cuboid. Hence, its y term could be known as 10. Finally, it acquires a similarity in vertical distance from the origin with known coordinate D, to be placed upon the bottom surface of the cuboid, hence being equal to a z term of 2. Thus, as an overview of this vector coordinate is considered to obtain an overall coordinate of 4, 10, 2. With reference to the general rule of deducing position vectors, this requires the subtraction of individual vectors in the form AB is equal to B minus A. As the question requires us to calculate the position vector of BE, this requires us to identify point E in the cuboid, to then be used for the given rule. Through repetition of the mentioned procedure, point E acquired a similarity with the x and y terms of point D's coordinate, being its horizontal distance and depth onto the shape. In terms of the vertical distance from the origin, a similarity could be found with points F and G to result in an overall vector 14, 3, and 7. With application of the given rule AB is equal to B minus A, we could subtract position vector BE through the form E minus B, where 14 minus 4 is equal to 10, 3 minus 10 is equal to negative 7, and 7 minus 2 is equal to 5. The final section of this problem would be to calculate the magnitude of AF, where this could be executed through 3 steps. Identify the vector of A, calculate the position vector AF, utilize magnitude formula to deduce the numerical value of the vector AF. As we are unaware of the coordinates of point A, we are able to execute the mentioned procedure where we evaluate the similarities of horizontal distance, vertical distance, and depth with the known coordinates to point A. This could result in the overall coordinate of 4, 3, 2. As the second step for this expression, we could then apply the general rule AB is equal to B minus A to calculate the position vector of point A and F to result in the position vector 10, 7, and 5. By determining the individual coordinates of the specified points A and F, as well as being able to calculate their position vector, we are now required to determine the magnitude of the specified vectors, which is completed through the standard formula root A squared plus B squared plus C squared, where we could substitute the given integers of position vector AF into this rule to obtain a magnitude equal to root 10 squared plus 7 squared plus 5 squared, which is equal to root 174. As an overview of answers, point B obtains the vector of 4, 10, 2. Position vector of points BE is equal to 10, negative 7, 5. And finally, the magnitude of AF is equal to root 174. As our following question, we are going to evaluate a scalar product and magnitude problem. The question states, the first 4 levels of a stepped pyramid with a square base are shown in diagram 1. Each level is a square-based cuboid with a height of 3 meters. The shaded parts indicate the steps which have a width of 1 meter. The height and width of a step at a corner are shown in the enlargement in diagram 2, with coordinate axes as shown and one unit representing 1 meter. The coordinates of P and A are 12, 0, 0 and 24, 0, 0. As a general note, three-dimensional vectors could be represented through the terms x, y, and z. These form three axes where an x term of a vector is equal to the horizontal distance of a point from an origin, whereas its y term is equal to the depth of a point upon a shape, and finally its z term is equal to the vertical distance of a point from its origin. The initial section of this problem would be to identify the unknown vector q with reference to the given information situated above. As we are aware that point q is situated upon the third step of the pyramid, where the width of one step is equal to 1 meter, it is considered to be situated 2 meters from the origin according to the x-axis. Hence, its x term could be equivalent to 2. In regards to its depth upon the pyramid, it is situated at the surface of the third step, in which the given shaded area is equal to 1 meter. Hence, we could identify that vector q is positioned 2 meters from the origin as per the y-axis to obtain a second term of 2. Finally, as each step obtains a length of 3 meters and point q is situated upon the upper edge of the third step of the pyramid, thus we are able to deduce its final coordinate by multiplying 3 by 3 to be equivalent to an overall vertical distance of 9 meters from the origin. Hence its z term is equal to 9. Thus the overall column vector of point q could be referred to as 2, 2, 9. As we are required to also identify point R, we could complete the equivalent procedure where we refer to the provided information in this problem to identify the x, y, and z terms of this point. However, a certain difference that could be noted would be to identify its x term, where we are required to evaluate the given vector of point A to be equivalent to 24, 0, 0. As R is positioned 3 meters from this point, we could subtract the x term 24 minus 3 is equal to 21 to be its overall x term. In regards to its y term, it is positioned 3 meters as per the y-axis. Finally, as point R is situated at the upper edge of the fourth step of the pyramid, where each step is equivalent to 3 meters in vertical length, then we are able to multiply 3 by 4 to be equivalent to its z term being 12. Hence, its vector is equal to 21, 3, 12. In regards to the concept of scalar product, this is calculated through the multiplication of a and b, as per the diagram, as well as an angle, when multiplied by logarithm cosine. This is rearranged whereas the angle is made the subject in this equation. This is equivalent to inverse cosine of scalar product of sides a and b, divided by the magnitude of vectors a and b. With application of this concept, we are required to calculate the scalar product and magnitude of vectors p, q, and pr as per the given diagram and problem. With the general rule of position vector, we can deduce that the vector pq is determined as 2, 2, 9 subtracted by 12, 0, 0 to be equivalent to minus 10, 2, 9, whereas pr is equal to 9, 3, 12. As a general understanding, the dot product is considered as a third vector operation, where it results with a scalar number to be seen as the following rule, where the dot product of v and w is equal to the product of a1 and a2 plus the product of b1 and b2. With application of this rule, the dot product pq and pr is equal to minus 90 plus 6 plus 108 to be equal to 24. As per the given formula required to deduce the angle of a triangle through means of vectors, we are required to calculate the magnitude of position vectors PQ and PR. This could be achieved through the standard formula of magnitude, which make up the three-dimensional coordinates of the vector. Hence, through this general rule, we could substitute the given column vectors as shown into the formula. Thus, magnitude PQ could be calculated as root 185, which should remain as a radical form due to accuracy purposes. On the other hand, the magnitude of PR is also equal to root 234. By deducing the dot product of the required vectors PQ and PR, as well as calculating the magnitude of each particular vector, this could be substituted in the given formula to determine the angle QPR, which is equal to 83.4. As an overview of answers, coordinates of Q and R is equal to 2, 2, 9, whereas point R is equal to 21, 3, 12. The angle QPR could be equal to 83.4. Question completed. A question states a remote-controlled toy car is initially at the point -3, -2. It moves with constant velocity 2I plus 4j. The distance units are centimeters and the time is in seconds. Crucial information regarding this toy car would be its original position at -3, -2 in graphical terms to obtain a constant velocity at 2I plus 4g centimeters per second. This could aid us in the initial problem where we are required to formulate a general equation that could indicate the position of the car at t times where t is larger than 0. By labeling the given information through terms where r is the new position of the car after activation, a equal to its original point, t being a particular time period, and b being its velocity in the form of a vector. To create the general rule, r equals a plus the product of tb. This could associate by how speed multiplied by time is equal to distance, where r being the new position is equal to the sum of the original position with the velocity and time period. Moving on, by substituting the given information into the corresponding terms, it creates the rule xy is equal to -3 -2 plus t multiplied by 2, 4, which was attained through the given vector 2I plus 4g. This could be further simplified to create the rule -3 plus 2t, which is utilized to deduce the x term, while -2 plus 4t could determine its y term. To determine the position of the car in terms of x and y at 2.5 seconds, we need to substitute this in the term t in the individual equations formulated per term, where -3 plus 2t to deduce the x term and -2 plus 4t to deduce the y term. Through calculation, we can deduce that its overall vector position is equal to 2, 8. In regards to the final section of this problem, we are required to plot the position vectors of the toy car at an x-axis range of 0, 0.51 to a period of 4 seconds. However, to present this in a clear manner, this is to be completed through means of tables that then be plotted as coordinates. Hence, by creating two individual tables for each equation needed to deduce the x and y term, this is to be completed through means of substituting the given time periods into the equation as displayed, to arrive at the given position vectors. To plot these points correctly, we need to identify the corresponding x and y terms per time period, where as an example, the position vector of the car at 0.5 seconds would be equal to -2, 0 from the second table. This concludes with a straight line where this question is completed. Now we're going to explore the concept of collinear vectors and ratios, in which a question states that points P with a vector of 4, 1, -2, Q, 5, 2, 0, and R, 7, 4, 4 are situated upon a straight line. A. Show that P, Q, R are collinear. As a method to determine whether certain points are considered as collinear, two aspects should be investigated, where these points should obtain a common point and a common multiple. This could be clarified through the definition of the term collinear, stating, collinear is used as the term to indicate that three sets of coordinates are situated at the equivalent or straight line. With this concept in mind, let us calculate the diverse position vectors, mainly with points P and Q, and position vector P and R, to indicate whether the points obtain a common multiple. Hence, with the application of the general rule for the calculation of position vectors, being referred to as AB equals B minus A, this could be modified to PQ equals Q minus P, where the subtraction of the individual vectors are equal to vector 1, 1, 2. On the other hand, PR could be subtracted to provide with result 3, 3, 6. We are able to identify a common multiple in which PR is larger than PQ by a factor of 3. Hence, we could further simplify this as 3 multiplied by the vector 1, 1, 2. This could be seen in the form of ratios, where PQ divided by PR is equal to 1 over 3. Therefore, as 3 multiplied by PQ is equal to PR, we could create the ratio being collinear vectors. In the following section, we're required to find the ratio of point Q as it divides the straight line PR. As indicated through the position vectors from P to Q, it is equivalent to 1, whereas from P to R, it increases by a factor of 3. Hence, this could be divided into 1 and 2. Therefore, as PQ is divided by PR, this could be substituted with the integers 1 over 2 to obtain an overall ratio of 1, 2. Question completed. Well done, and thank you for listening.